Hi guys, Aaron Nunley here with Nunleymath. I just wanted to take a couple videos and talk about what I'm calling my Nunleymath Professional Development Series, where I focus on specific topics that teachers have told me are difficult for them to teach. Or another way to say that is ideas that students struggle with, and we're going to just spend some time talking about some things we notice and maybe offer up some suggestions that might help those teachers to present information in a way that might be a little more useful for students. So topic number one was given to me by one of my favorite teachers, one of the best math teachers I know. She asked, how can I help my students use and understand units in solving perimeter, area, and volume problems? Now this idea of perimeter, area, and volume problems is really something we spend a lot of time focusing on in 6th, 7th, and 8th grade math, junior high level, which is what I teach. So what I did is I went through my state's standards. These are the Ohio State Standards for Geometry, listed out by grade level. Now I did condense them and summarize them, so they're not in fancy formal math language, but we're not being really formal here. And I just want to talk about these for just a moment and point out some things that I noticed. First of all, notice that in 4th grade, students begin talking about the area and perimeter of rectangles. In 5th grade, they begin talking about the idea of volume in terms of counting unit cubes, both recognizing and finding the volume. 6th grade, we talk about area of triangles, special quadrilaterals, and polygons. Composed of those, we talk about the volume of rectangular prisms a little more formally, and we begin talking about the nets of 3D shapes and the surface area of objects, but notice it's limited to rectangular and triangular faces. 7th grade, we talk about the area and circumference of a circle, as well as the surface area and volume formulas for prisms. And then finally, in 8th grade, we talk about the volume of pyramids, cylinders, cones, and spheres. And I listed these out the way I did on purpose because sometimes I think it's very easy for us to focus on the specific standards we cover without really reflecting on the standards that lead up to or follow our lessons. So here's some things that I noticed and observed as I was reading through this, and I would suggest that you pause and reflect on these yourself before hearing what I have to say on them. First of all, I was really surprised when I looked at these at how late the geometric formulas are introduced. We spend a lot of time in Common Core style teaching where we develop ideas behind formulas before using the formal formula that most of us as teachers memorized in school. That wasn't altogether surprising, but the timing on that really was. Like, I was really shocked that students up until 6th grade really hadn't talked about the area of triangles. So when I see 7th graders in my class, I really shouldn't be so surprised when that's unfamiliar to them. Second, prior to 7th grade, students have only seen the area formula for a square and a triangle. I thought that students had worked a lot with area formulas before they come to me, which actually is not the case. Prior to 7th grade, students have only seen the volume formula for a rectangular prism. They've not talked about volume outside of purely rectangular shapes. So we start talking about cylinders and we start talking about cones and spheres. We should not be surprised that that is news for them. Students don't discuss circle formulas really at all until 7th grade. Now, I'm sure in early elementary they spend some time learning what a circle is, and I'm sure a lot of you, like me, have students that know about pi, even though they really don't know what pi stands for. But circles are really brand new to our students. I was really shocked about that. Which means that as a middle school teacher, I really need to adjust my expectations and begin to expect my students to struggle more with these concepts than I traditionally have. Especially those of us that have been teaching for a while. I think we have these assumptions of our students coming in that they will have encountered the same formulas we might have encountered in early elementary school, when really that is not the case. So in answer to the original question, how do we begin to help students differentiate between length, area, and volume? I think it begins with just understanding that these are new concepts to the students. These are not review concepts. So we have to make sure we teach them as new concepts. So here's strategy number one that I would suggest. We need to make sure we're talking about what dimensionality is. And when I say dimensionality, what I'm saying is, do students really know, or do we even really know, what it means for an object to be 1D, 2D, or 3D? So when we talk about distance, area and volume. We need to make sure that students realize that distance is measuring one direction at a time, area is measuring two directions at a time, and volume is measuring three directions at a time. So when I talk about length, that's one dimensional. When I talk about height, that's one dimensional. When I talk about width, that's one dimensional. And so when we begin to talk about measuring how long edges are, we're talking about things like centimeters and inches and feet. But when we begin talking about area, we're talking about measuring in two directions at the same time. Either we're talking about a length and a height, or we're talking about a width and a height, or we're talking about a length and a width. Notice I switched length and width here. I need to be a little more conscientious about there. The point is, area gives us a way to measure a flat surface or two directions at a time. That's different from volume, which allows us to measure in all three directions at a time. So when I'm talking about distance, I'm thinking about measuring one dimension. Like, would I measure this with a string? How long would the string need to be? When I start talking about area, I want to make sure I'm talking about covering things with squares. And when I talk about volume, I want to make sure I'm talking about filling with cubes. And often, if you refer to it in terms of measuring with strings, covering with squares, or filling with cubes, that really helps the students in their mind to differentiate which unit they need to be using. So if I say, would you cover it with squares or fill it with cubes? They say cover it with squares, then they're talking about inch squares, centimeter squares, feet squares. Whereas if they're filling it with cubes, then we would do cubic inches, cubic feet, cubic centimeters. Strategy number 2, take the time to develop the formulas. Don't just restate them and expect the students to understand how to do it. We spend a lot of time in my class when we talk about something like the area of a parallelogram, talking about the fact that we are finding area, which means we're filling it with squares. But the students need to understand that because we don't have right angles in our parallelogram, the squares do not fit. How then do we develop the formula? Well, it's important that we take the time to explain to them that if we were to move this left side, this green portion of our parallelogram over to the other side, well, now things fit nicely because we have right angles. That's a very important concept for students because when they see something that doesn't have right angles, they forget that they're still dealing with squares. We need to show them that we can force squares to fit here. And I certainly have some longer lessons on how I do that, and you can look those videos up, how I teach area of a parallelogram to my students. But it is important, at least in this video, for us to acknowledge that we need to go through that process with them. When we talk about the area of triangles, we need to talk about the fact that we're still filling it with squares, but they don't fit. However, if we take two congruent triangles, we can actually make a rectangle and we can make these squares fit. Again, I do that in much more detail in my lesson that you can look up here on YouTube. When we do circles, circles are kind of cool. You can actually make a really fun lesson for this for your students. And you can talk about how if you cut this into wedges, you can make something that approximates a parallelogram. You can also talk about the fact that if you were to cut these into much smaller wedges and smaller wedges infinitely down, you could actually force this to have what we would see as straight line sides. And you can develop your circle formula from there. Again, always referring to the fact that we have to create formulas based on what lets us fill it with squares. When we do volume, we do the same thing. We talk about how area is filling with squares, but when we talk about volume, we do the exact same thing with cubes. Notice the image on the left is 24 square inches, the image on the right is 24 cubic inches. Very important for you to actually have that conversation with the students because all we've done is shift from squares to cubes, and now we have three-dimensional figures. Again, this is in my lesson for them. Once my students understand 3D figures, I begin talking about stacks. Cylinders and prisms are all about stacks, and that idea of stacks is how we begin to develop our length times width times height, or for future shapes, whatever shape the base is, we're going to deal with stacks or layers in order to create these 3D figures. And again, I go into that in much more detail if you go back and look at my volume lessons. Strategy number 3, always talk about volume in terms of layers and stacks of cubes. A rectangular prism is just a rectangle plus another rectangle stacked on top, stack, stack, stack. When we talk about triangular prisms, notice I go from 2D to 3D. Now it's cubic inches. And then I begin, or in this case cubic centimeters, and then I just do stacks of those. When we talk about cylinders, it's just stacks. That helps us develop that idea of area of the base times the height. Strategy number 4, we want to make sure we're using informal language with our students before using formal language. So for example, I don't want to ask my student necessarily right at the beginning, what is the area? What I want to do is ask them, how many squares will it take to cover this? And then we go back and prompt them for the term area. I don't want to necessarily start off by saying centimeters squared. Instead, I want to say squares with 1 centimeter sides, and then ask them to recall the term. I don't want to say cubic inches or ask about cubic inches necessarily. I want to talk about 1-inch cubes. Notice it's very small, subtle changes in my language as a teacher that's connecting this symbol back to its geometric equivalent. Last strategy, strategy number 5. Keep it connected and go back often. Keep it connected and go back often. So we measure the area of squares, we're measuring with squares because they make rectangles. When we understand that, we take our other shapes and we talk about how we have to rearrange them or shift them to make those squares fit. When we talk about surface area, it's still covering with squares, still turning other shapes into rectangles that can be filled with squares. When we talk about volume, we're talking about filling things with cubes. And then we talk about volume as being layers or stacks. Cylinders and prisms are just layers and stacks on layers stacked on top of each other, regardless of what the basic shape is. And then we can go in and we can talk about cones and pyramids being 1/3 of whatever prism or cylinder is made by their base shape. And then lastly, I talk about a sphere being just 2 cones, or being 2/3 of the cylinder. Again, I don't want to go too far into detail about the specifics of each individual shape. If you want to learn about that, you can look up my lessons that I present to my students on those topics. But these 5 strategies should go a long way in helping your students to build those connections they're going to need. And once they make those connections, really understanding and writing the correct units becomes a much simpler process for them. Hope this is helpful to you. If you have questions you'd like to have me answer, go ahead and leave me a comment in the comment section down below. I'll do my best to answer those in future videos. Thank you so much for paying attention. I wish you all the very, very best. Take care of yourselves. Bye-bye.